Welcome to Mythos AI, your source for Cliff's Notes on complex subjects. Join Anna and Phil for yet another engaging conversation.
Welcome to our deep dive into the world of the Taiwan Semiconductor Manufacturing Company, more commonly known as TSMC. Today we'll explore how this company has become much more than just a manufacturer, impacting artificial intelligence, influencing strategic business decisions, and playing a central role in global geopolitics.
To fully grasp TSMC's present-day significance, we need to look back at the historical context of Taiwan's emergence as a semiconductor powerhouse. This journey involved a combination of strategic government initiatives, a favorable geopolitical environment, and a dedicated focus on cultivating a skilled workforce. Taiwan's government played a crucial role in laying the foundation for a thriving technology ecosystem. They strategically invested in education, technology, and infrastructure. These investments fostered a highly skilled workforce of engineers and scientists who have been instrumental in propelling Taiwan to the forefront of semiconductor technology.
Political stability and a strong legal framework despite existing regional tensions also played a critical role.
These factors created a secure and attractive environment for both domestic and foreign investment, allowing businesses to flourish without undue political or legal risks. Taiwan's strategic geographical location, situated at the crossroads of major trade routes in East Asia, provided logistical advantages connecting it to key markets in the United States, China, and Europe. This combination of factors created fertile ground for a company like TSMC to emerge and thrive.
Before TSMC revolutionizing industry, most semiconductor companies operated under the Integrated Device Manufacturer or IDM model. This meant that companies designed and produced their own chips in-house. However, as chip designs became more complex and the technology required for manufacturing advanced, the IDM model proved increasingly costly and inefficient.
TSMC recognized this shift and pioneered the pure-play foundry model, choosing to specialize solely in manufacturing.
This allowed companies that excelled at chip design, but lacked the expensive and complex fabrication facilities known as fabless companies to outsource their production to TSMC.
This specialization allowed TSMC to focus all its resources on building cutting-edge facilities, refining their manufacturing processes, and achieving remarkable efficiency and quality. In doing so, they fostered a collaborative ecosystem where fabless companies concentrated on design and innovation, while TSMC took care of perfecting production techniques. This symbiotic relationship resulted in rapid technological advancements within the semiconductor industry.
This pure-play foundry model has reshaped the industry landscape. But to truly understand its significance, it's important to understand the complexities of semiconductor manufacturing. At the core of all our electronic devices lies the semiconductor chip, a tiny piece of silicon packed with billions of transistors that process information. These chips are essentially the brains of your phone, laptop, and even your car. Designing these intricate circuits is a highly specialized field.
The process begins when a fabless company submits its detailed chip design to TSMC. TSMC engineers then create silicon wafers, which are thin slices of semiconductor material that act as the foundation for the chips. These wafers undergo a series of intricate processes. One of the most critical is photolithography. It's a technique using light-sensitive materials and processes to etch the intricate circuit patterns onto the wafer. After the patterns are etched, a combination of chemicals and heat is used to modify the wafer, further building the transistor structures. This stage is known as etching and doping.
Once the wafers are complete, they are cut into individual chips, packaged, and rigorously tested to ensure they meet the required specifications. They are then shipped to the fabless company for integration into their final products. This specialization allows TSMC to focus exclusively on production, constantly refining its manufacturing technology and achieving economies of scale that would be impossible for companies trying to manage both design and manufacturing.
This results in lower costs and higher quality chips, which benefits consumers and drives innovation across the entire tech industry. TSMC's dedication to research and development has enabled them to consistently shrink the size of transistors, leading to more powerful and energy-efficient chips. This relentless pursuit of miniaturization has been a key driver of the exponential growth and computing power we have witnessed over the past few decades. TSMC's impact extends far beyond simply supplying chips. The company's innovations are intrinsically linked to the advancement of artificial intelligence, a field that is rapidly transforming industries ranging from healthcare to transportation. At the heart of this AI revolution are high-performance chips capable of processing massive amounts of data quickly and efficiently. TSMC plays a vital role in this by producing the most advanced chips using cutting-edge process nodes like the 5 nanometer and the forthcoming 3 nanometer technologies. These nodes enable the creation of chips with an incredibly high density of transistors, crucial for AI applications that demand rapid data processing and energy efficiency.
The performance enhancements TSMC delivers directly impact the capabilities of data centers where AI models are trained and the performance of edge computing devices that bring AI capabilities to our everyday lives.
This translates to faster training times for AI models and real-time processing capabilities, which are essential for applications like autonomous vehicles, medical diagnosis, and personalized recommendations.
TSMC's influence doesn't stop at technological advancement. It extends to the geopolitical landscape, where its role is increasingly significant. This is primarily due to the company's dominant position in the semiconductor market and the strategic importance of Taiwan, where the majority of its production facilities are located.
While TSMC's primary production facilities are based in Taiwan, the company is strategically expanding its global footprint. In the United States, TSMC is building state-of-the-art fabs in Arizona.
This move is driven by several factors. Firstly, it strengthens supply chain resilience. By diversifying production geographically, TSMC reduces its vulnerability to regional disruptions or geopolitical tensions.
Secondly, having a fab in the U.S. means shorter lead times for American customers, strengthening partnerships with major tech companies.
The U.S. government is also offering significant incentives, including subsidies and tax breaks, to encourage domestic semiconductor manufacturing, making the proposition even more attractive for TSMC. This expansion strategy, however, is not limited to the United States.
TSMC has similar initiatives underway in Japan, partnering with Sony and the Japanese government to establish a new fab, tapping into Japan's technological expertise and strengthening its presence in a key market. There are also potential moves into European markets being considered as part of a global diversification strategy.
This global expansion is about more than just mitigating risk. It's about establishing a stronger global presence, diversifying revenue streams, and solidifying TSMC's position as a crucial supplier in an increasingly multipolar world. To fully understand TSMC's position in the global business landscape, we can use two key frameworks, PESTLE and SWOT. The PESTLE framework, which stands for Political, Economic, Social, Technological, Legal, and Environmental, helps us analyze the various external factors that could impact TSMC's operations.
Politically, TSMC operates within the complex dynamics of U.S.-China relations and regional security concerns in East Asia. However, it also benefits from favorable government policies and incentives from Taiwan, the U.S., and other countries supporting its expansion and innovation efforts. Economically, TSMC enjoys high demand for its advanced chips driven by global trends in AI, 5G, and the Internet of Things. However, it also faces potential vulnerabilities from trade disputes and economic fluctuations that could affect raw material availability and production costs.
Socially, TSMC relies on a highly educated and specialized workforce, meaning its success hinges on attracting and retaining top talent. It also faces increasing pressure to embrace sustainable practices and contribute to local communities. This is a key factor in maintaining a positive public image in a world where corporate social responsibility is increasingly scrutinized.
Technologically, TSMC maintains its competitive edge through continuous investment in research and development and state-of-the-art manufacturing processes. However, the rapid pace of innovation in the semiconductor industry requires constant adaptation and the need to push beyond the limitations of traditional scaling methods like Moore's Law. Legally, TSMC must navigate the complexities of intellectual property protection and compliance with international trade regulations. Environmental regulations also play a crucial role, as compliance with environmental standards is paramount for global operations.
From an environmental standpoint, TSMC is making considerable efforts to reduce energy consumption, water usage, and carbon emissions. This commitment to sustainability not only aligns with a positive corporate image, but also addresses increasing regulatory and market pressures for responsible practices.
Complementing the PESTLE analysis of SWOT analysis helps us assess TSMC's internal strengths, weaknesses, opportunities, and threats. In terms of strengths, TSMC boasts undisputed technological leadership, dominating the advanced semiconductor manufacturing landscape. Its long-standing strategic partnerships with global technology giants ensure a steady demand for its products. Furthermore, TSMC has a proven track record of innovation, consistently pushing the boundaries of what's possible in semiconductor manufacturing.
However, despite these strengths, TSMC also faces weaknesses. Its heavy reliance on Taiwan for production makes it vulnerable to geopolitical risks and regional instability.
The capital-intensive nature of the semiconductor industry requires continuous heavy investment in technology upgrades, putting pressure on its finances. Additionally, a significant portion of TSMC's revenue comes from a handful of major clients, making it susceptible to fluctuations in their demand.
Despite these weaknesses, TSMC has numerous opportunities for growth. Its ongoing global expansion by establishing fabs outside Taiwan can diversify risk and tap into new markets.
The rising demand for advanced chips fueled by the growth of AI and 5G technologies presents a significant market opportunity. Furthermore, TSMC can leverage its investments in sustainability and green technologies to enhance its reputation and attract new customers who prioritize environmentally responsible practices.
However, TSMC also faces potential threats. Escalating geopolitical tensions or conflicts in East Asia could disrupt its operations, which are heavily concentrated in Taiwan. As Moore's Law approaches its physical limits, TSMC needs to find new ways to innovate and maintain its technological advantage. Changes in trade policies, such as new tariffs or trade restrictions, could also impact TSMC's global competitiveness. TSMC is actively pursuing strategic initiatives to address these challenges and solidify its position in the evolving technology landscape. One of the most prominent responses to growing geopolitical concerns and calls for diversified supply chains is TSMC's global expansion strategy. This involves establishing manufacturing facilities in key regions worldwide, reducing their dependence on Taiwan as the primary production hub.
The new fab in Arizona is a significant step in this direction. This facility, built with substantial investment from TSMC and supported by incentives from the U.S. government, aims to secure a more stable supply chain for U.S. companies and reduce potential disruptions caused by geopolitical events. This move is not only about diversifying physical locations, it also signifies a deepening of ties between TSMC and the United States, a crucial partnership in the current geopolitical climate.
TSMC's expansion strategy extends beyond the United States. Their collaboration with Sony and the Japanese government to establish a new fab in Japan taps into Japan's renowned expertise in electronics manufacturing and strengthens TSMC's presence in a key market for consumer electronics and automotive technologies. These strategic moves demonstrate TSMC's understanding of the evolving global landscape and its commitment to building a more resilient and geographically balanced supply chain.
Beyond geographical diversification, TSMC is increasingly focused on sustainability, recognizing the environmental impact of semiconductor manufacturing and responding to growing global concerns about climate change and responsible resource management. They have set ambitious targets for reducing greenhouse gas emissions, water consumption, and waste generation. This commitment involves investing in renewable energy sources, implementing energy-efficient manufacturing processes, and promoting circular economy principles to minimize resource use and waste.
These efforts are not solely driven by altruism. They represent a strategic understanding of the increasing importance of sustainability in the global marketplace. Consumers are becoming more discerning, favoring companies that demonstrate environmental responsibility. Investors are also increasingly factoring in environmental, social, and governance (ESG) considerations when making investment decisions. By embracing sustainable practices, TSMC is enhancing its corporate reputation, strengthening its brand image, and positioning itself as a leader in sustainable manufacturing, which will be crucial for attracting both customers and investors in the future.
The looming end of Moore's Law, the principle that has guided the semiconductor industry's exponential growth for decades, presents a significant challenge. TSMC is confronting this challenge head-on by investing heavily in research and development, focusing on innovative solutions that will drive performance improvements beyond traditional scaling methods.
One key area of focus is advanced lithography techniques, particularly extreme ultraviolet (EUV) lithography. EUV enables the creation of smaller and more densely packed transistors, pushing the boundaries of miniaturization further than previously possible. This allows TSMC to continue improving chip performance, even as the physical limitations of traditional scaling methods become increasingly apparent.
In addition to EUV, TSMC is exploring new chip architectures like 3D stacking. This approach allows for the creation of more powerful chips by stacking multiple layers of transistors on top of each other. This increases transistor density and improves performance without solely relying on shrinking individual transistors, offering a pathway to continued performance gains.
Another crucial area of exploration is the research into new materials to replace or augment silicon, the traditional material used in semiconductors. Materials like graphene and silicon carbide offer the potential for significant performance improvements due to their unique electrical and thermal properties.
These investments in post-Moore's law technologies are essential for TSMC to maintain its technological leadership in the semiconductor industry. By embracing innovation and adapting to the evolving technological landscape, they are positioning themselves for continued success in a world where traditional scaling methods will no longer be sufficient to meet the growing demands for computing power.
TSMC's journey is a compelling case study of how a company can become a linchpin in the global economy, a vital player in international relations, and a driving force behind some of the most transformative technologies of our time. Their strategic decisions, from embracing the pure-play foundry model to navigating the complexities of global expansion and sustainability, provide valuable lessons for other companies operating in an increasingly complex and interconnected world.
TSMC's story is a testament to the power of innovation, collaboration, and strategic vision. As we move forward in an era of rapid technological advancements and increasing geopolitical complexity, their journey offers valuable lessons for businesses, governments, and individuals alike. Their ability to navigate these complexities, adapt to new challenges, and seize emerging opportunities serves as an inspiration for anyone seeking to thrive in a world defined by constant change. We hope this deep dive has provided you with a nuanced understanding of TSMC, its impact on the technology landscape, and its strategic vision for the future.
Thanks for listening to Mythos AI. Stay tuned for more concise insights. And remember to hit the like button and subscribe for future episodes.